these two simultaneous equations. We're going to solve these two. And one way I'm going to do it is I'm going to place them above each other. And hopefully this is something that we're quite comfortable with. If not, this might be a good recap. I have the 3a plus 5 equals 170. That's from our triangle. 9a plus 7b is equal to 310. Now, I can't really do much with this. My goal is to figure out a way to cancel one of these variables. There's two variables in here that overcomplicates things somewhat. So I want to cancel them out. And so what I decided to do is I've decided to multiply the top one by 3. So what you will see, therefore, is 3 times 3 is 9, 5 times 3 is 15, 170 times 3 is 510. Now, these two match. Now you'll see that the 9a's match quite comfortably. Because they match, I can subtract from them and get 0. So you can see here, 9 take away 9 is 0a. So I no longer have two variables, I only have one. Right? And this is plus 15. 15 take away 7 is 8. And 510 take away 310 is 200. Therefore, I have 8b equals 200. Divide both sides by 8. This is times by 8 on the left-hand side. So if I want to get rid of times by 8, divide both sides by 8. I have b equals 200. This would say here, divide by 8 on this side. So if I divide by 8 there, and I would divide by 8 on this side, like so. And 8 divided by 8 is 1, leaving me just with b. 200 divided by 8 is 25, and so b is 25. And that's me having solved the simultaneous equation. But only partly solved, because I know what b is. I do not actually have a value for a. And so that's normally where the other mark comes from. And so what I'm going to do is I'm going to move onto these equations again. The first one, the 3a plus 5b we got from our triangle. The 7b plus 9a we got from the quadrilateral. Remember where that came from? That came from the fact that we know that angles in a triangle add up to 180, and we know that angles in a quadrilateral, a four-sided shape, add up to 360. Then we did some basic simplification, some rearrangement, and we've got this. I've done simultaneous equations now, and I know that b is equal to 25. That's what I know. b here is equal to 25. Okay, now seeing as that's the case, I can implement that. Notice that there's a b here, and I simply go, right, if that's b, now I'm going to call it 25. Also with the second one, there's a b instead of this b there, I can call that 25. Now it's up to you. You could use either one of these equations from now on. You could see that quite comfortably. I can now rearrange this for a, or I can rearrange this for a. It's up to you. It depends on which one you feel comfortable with at the time. I'm going to use the example as the top one, just because it just looks more simple to me. 3a plus 5 times 25 is 170. 5 times 25 is 125. So it's 3a plus 125. Now, you know in these situations, I always do this with algebra. I know that this is a step that we don't actually need to keep repeating, but it's useful. If I want to get rid of that 120, I have to minus 125 from both sides. I want to get rid of the 125. These are going to cancel. 125 take away 125 is 0. So 170 take away 125 is 45, and so I'm left with 3a equals 45. Divide both sides by 3. a equals 45 over 3. And as a result, I have found my answer for a. a is 15. So I can answer this question, and I think I'll do that before we take a minute break. It says find the size of the smallest angle of the triangle. Now if we take a look, there is our triangle. It's quite obvious that this is 2a, mainly because this is a plus b. This is an addition concept in it. So it's 2a. So the angle that is the smallest is 2 times a. And as a result of a little bit of maths, a is 15. So I said b is 25, a is 15. The smallest angle is 2a, which is 2 times 15. So it's 30 degrees. Notice that I state the degrees, and that is the smallest side of our triangle.